There exists a solar system situated approximately 4.5 light-years distant from Earth, which comprises not merely one or two, but indeed three stars. Two of these stars are designated as Alpha Centauri A and Alpha Centauri B. The third star is commonly referred to as Proxima Centauri. If you are not already aware, permit me to inform you that Proxima Centauri is indeed the nearest star to our solar system, and its average distance is approximately 4.24 light-years, which translates to roughly 41 trillion kilometers. This particular stellar system is the nearest three-body system that has been discovered in the entire universe, and the fascinating aspect is that we have examined it quite comprehensively. Scientists assert that the triad of stars within this specific star system is remarkably stable, which is truly quite remarkable. Even more intriguing is this. Alpha Centauri and Beta Centauri exhibit quite extraordinary similarities to our Sun. Their age, chemical composition, lifespan, and even their luminosity and temperature are nearly identical to one another. These two stars exist in a binary relationship, which signifies that they orbit around each other. Meanwhile, the third star within this particular star system, known as Proxima Centauri, revolves around this binary system. In general, a three-body system typically tends to be quite unstable. Even a minor alteration can result in chaotic behavior. If you are not familiar with this concept, within a gravitational system, it pertains to a random occurrence initiated by something very small. In a three-body system, even a slight modification can lead to significant changes. We observe such substantial and significant final changes that predicting them becomes nearly impossible. You can compare this to the butterfly effect, which suggests that the flapping of a butterfly's wings can eventually create something as dangerous and powerful as a massive storm. This might sound somewhat peculiar and quite difficult to believe, yet we observe numerous instances of it all around us. Furthermore, the chaotic system has been thoroughly examined on numerous occasions through the application of mathematics. Scientists assert that, in contrast to a conventional three-body system, the Alpha Centauri system is not nearly as chaotic. The trio of stars within this particular system exhibits remarkable stability and orbits one another in a peaceful manner. At this juncture, you might be curious about how these three stars manage to orbit one another while maintaining a stable trajectory. The answer, in actuality, is hidden within the orbital trajectory of Proxima Centauri. Proxima is a very small star with a mass approximately 10 times less than that of the Sun. Due to its lower mass, its temperature and brightness are also significantly reduced, making it almost impossible to observe in the night sky without a telescope. Now, although we are unable to observe many stars in the vastness of space without the aid of a telescope, Proxima Centauri is indeed the nearest star to our planet, and yet it still remains unseen in the night sky. According to researchers, there are relatively high probabilities that Proxima was not originally formed within the Alpha Centauri system, but rather in a different location. After being expelled from its original solar system, it probably became ensnared in the gravitational pull of the Alpha Centauri star system and has been revolving around it ever since. As I previously mentioned to you, typically three-body systems tend to be rather chaotic, but this is not the situation with Alpha Centauri. This is due to the fact that within this system, the gravitational influence exerted by Proxima Centauri is quite minimal. One might even say it is nearly negligible. This particular star orbits the primary stars of this system from a distance of approximately 15,000 astronomical units. An astronomical unit, commonly referred to as an AU, represents the mean distance between the Sun and our planet Earth. Bearing this in mind, you are able to estimate the distance at which the Proxima Alpha star is positioned. For the sake of comparison, these two alpha stars sustain a separation of roughly 23 astronomical units from one another, which is adequate to sustain a stable orbit. If these stars were even marginally nearer to one another, this stellar system might have been obliterated a long time ago. This would occur because the gravitational forces of these two stars would commence drawing each other's matter towards themselves, disturbing the equilibrium of the entire stellar system, and ultimately only a single star would remain alive. In the scenario of binary star systems, this particular phenomenon is regarded as quite a typical occurrence. Scientists have frequently observed that within a binary system, one star begins to progressively consume the other star. This process continues until the entirety of the smaller star's matter is completely transferred to the larger star. Indeed, no such phenomenon has been detected between the Alpha Centauri stars that might imply these two stars are remarkably stable. Experts elucidate that Proxima holds a significant role in preserving the equilibrium of this entire stellar system. Positioned at a considerable distance from the Alpha star, its gravitational impact does not extend to them in substantial quantities. You will be astonished to discover that it requires Proxima approximately between 500,000 and 1,000,000 years to accomplish a single orbit around these stars. From this information, you can envisage how expansive such an orbit must be.